Good morning, my friends and followers. I remain Edward Washroom. This morning I will be doing a video on ECM. I will teach you how to estimate a simple error correction mechanism and how to have them interpreted. Remember the day I actually presented a video on how to take decision on time series study. I actually told you that for you to estimate or perform an error correction model, you must perform Johansen co-integration test. And for you to perform Johansen co-integration test, it is expected that all the variables you are working with were stationary after first differencing. When variables are stationary after first differencing, it implies that there is a unit truth problem in the data set. And when there is a unit truth problem in a data set, it means that those data did not revert to their means rather. When data do not revert to its mean value, it then means that there is a unit truth problem. And for a data to be useful to you, the unit truth problem must be solved. Just like for a human to be actually useful, the sickness must be removed. So this morning I will be adopting a study approach where I will look at how some governance indicators affect economic growth in Nigeria. So stay tuned to my channel as we proceed. The first thing to actually do when you are actually estimating an error correction mechanism is to actually know the appropriate lag length. To do that, I will go to quick. I'll go to estimate var. I will specify my model. My model is log of RGDP, control of corruption, government effectiveness, regulatory quality, and trade openness is added into the model without changing anything here. If you hit the OK button, you will be exposed to a var output that looks like this. The next thing is to go to view. In the result, you go to lag structure, you maneuver to lag length criteria. You click on OK, then you will now be exposed to this. This is called var lag order selection criteria. Estimated this day. In this result, they are all endogenous in nature. The next thing you do is to identify the particular information criterion you want to actually use as your baseline information criterion. But it has a rule. The rule of two is that the lower the value, the better the model. But in my case, I will be using the SWAS information criterion because of the principle of consistency. I used SWAS information criterion previously in my unit 2 text, so it is expected that we need to continue with the SWAS information criterion to uphold that principle. Having known that my lag selection this morning is SWAS information criterion lag 2, I will now proceed to estimate my error correction model. But before I will estimate my error correction model, I will need to generate a new series called the error correction term. The error correction term can only be generated by going to the Eview work file. You go to the generate series button. You now click ECM equal to receipt. After conducting your unit 2 test, you have to click this. Once you do this, you click OK. If you click OK, you will generate a new series called ECM. This ECM will have the same value with your residual, which is also in the worksheet. So once you are able to generate your ECM, you now proceed to actually estimate your error correction term. So for me to actually estimate my error correction model, I will go to quick. I'll move on to quick in the Eview worksheet. If I move on to quick, I move on to estimate equation box. This box will open. This equation specification box, I will actually type in my model. I've already typed it previously. I put it from where I typed it to actually drop it into the box. We have the lag value of all the variables in lag 1 and lag 2, but the variables must be specified in their differences. We have first and second difference, and the ECM term in first difference. Without changing any other thing, if you hit OK here, you are going to be generating what they call over-parameterized error correction output. This over-parameterized ECM is actually the baseline results and is not actually what you needed for your explanation or interpretation. What you need is parsimonious error correction output, but there are two ways to actually produce a parsimonious output from a parameterized result, because you need to reparameterize this result again to get the parsimonious ECM. But the basic thing you are supposed to note from the over-parameterized result is the R-square adjusted. The R-square adjusted of the over-parameterized ECM is expected to be lower than the R-square adjusted of the parsimonious ECM for those eliminated variables to be actually not desirable in the model. So to do that, we have two approaches. We have two methods or two procedures through which we can actually generate the parsimonious ECM. The first approach is to actually re-estimate by eliminating the grossly insignificant variables. Like what we have here, we have the second log of the dependent variable is grossly insignificant, so we can now remove it from this equation. From this equation, we have removed the second log of the dependent variable. We now go to the first log of the control of corruption is also insignificant, grossly insignificant. We remove the first log of control of corruption. We move on to government effectiveness. Second log of government effectiveness is grossly insignificant. We actually eliminate second log of government effectiveness. We move on to first log of regulatory requirements is also first and second log of regulatory requirements. They are also grossly insignificant. We can now eliminating them. They are not part of the model. Then lastly, we go to the second log of trade openness, and we also eliminate that. Once I'm done with that, I hit the OK button. I will now get a parsimonious encompassing error correction mechanism. Though I still have 1, 2, 3 variables that are insignificant in the model. You can further remove these ones if you actually feel that they are not significant and you don't want them in the model. You can actually remove. I can further re-estimate again. I can further eliminate second year of control of corruption. I can further eliminate second year of control of corruption. Yes, I can further eliminate that to get a better parsimonious outcome. So this is called parsimonious encompassing ECM. In this parsimonious encompassing ECM, the R-square adjusted is approximately 67%, which implies that 67% of the variation in RGDP can be explained by the interplay of the variables used in this model, and that is also better, is far above the average. But my concern is that the ECM value is insignificant. It's also not negative. The ECM value is expected to be insignificant and negative for it to be acceptable. But if you look at this result, we have the C is the average of the distribution. The autonomous component is significant, while the past realization of the dependent variable is also positive and significant, which means that RGDP has a feedback impact on itself. If you look at the control of corruption series, it has a positive impact on control of corruption has a negative impact on economic growth, but it is not significant. That means that control of corruption is not an indicator, or it does not stimulate economic growth in Nigeria. We have government effectiveness and its lag value. Each 1 year lag value, they are having mixed impact or mixed effect on economic growth. That means that government effectiveness has a stable impact on economic growth in Nigeria, and because they are also significant, the p-values are less than 5%. We have regulatory quality is positive, but it's not significant. Trade openness and its first year lag values are significant, but it has an unstable impact on economic growth. So this is the first way to generate a parsimonious encompassing ECM. To actually get the second approach to it, I'll go back to my baseline over parameterized ECM. This is my baseline over parameterized ECM to actually generate a parsimonious error correction model through a different approach. We go to view. From view, you go to coefficient diagnostics. From coefficient diagnostic, you go to redundancy variable test, log likelihood. You now only specify those variables that are grossly insignificant. Like what we had previously, I had the log of the second year value of the dependent variable. Like what we have here is not significant, so I've specified it. The next one will have the first year lag value of the control of corruption. I also specify that, so I'll only specify the most insignificant coefficient The next one will have the second year lag value of the control of corruption is here. Then what we have again, we have the second year lag value of government effectiveness, second year lag value of government effectiveness, second year lag value of government effectiveness already specified. We have the regulatory quality first and second year. Regulatory quality first and second year will also be specified. Regulatory qualities first and second year will also be specified. Okay. Then the last but not the least, we have the second year lag value of trade openness. The second year lag value of trade openness will also be specified. So these are the most insignificant parameters we actually want to specify. So this is how to generate the second phase of error correction output. We have the most insignificant parameters removed, and we have a better parsimonious outcome or output here. This is what we have generated. Like the previous ones, we actually have an ECM value that is insignificant and not negative, and I'm not comfortable with it because the ECM ought to be significant and negative. The arrow square value of the parsimonious ECM should be greater than that of the over-parameterized ECM. The issue of the Watson statistics is okay. 1.96 is greater than, it's between the band of 1.5 and 2.5. The F statistics is okay, but my concern is that the ECM value is not significant and is not negative. So this is actually how to generate. These are the two phases of how to generate the parsimonious encompassing error correction output. Thank you for staying tuned to Edward channels and Edward Academy Radar. I want you to always subscribe to my channel, always view my channel, and I promise to actually expose further development in macroeconometrics. Thank you for watching my video this morning, and God bless you.